Peace be upon you. I'm Yusuf Mati. Today, God willing, we are starting our first series on this channel. We will be talking about pressure vessel inspection. We will discuss the topic from a practical perspective. Of course, we will refer to the applicable codes, standards, and recommended practices, but our primary focus will be on practical applications. If you have pressure vessels at your site and need to inspect them, or if you want to understand what pressure vessel inspection is, and how to determine whether something is a finding or not, we will discuss everything step by step. We will start with the objectives of this playlist. If you follow this playlist until the end, you will gain a solid amount of knowledge and practical understanding. First, we will introduce pressure vessels, what they are, their types, and their main components. Then we will discuss the different inspection types performed on pressure vessels. We will cover the 4 main inspection methods, including external inspection, internal inspection, on-stream inspection, and thickness measurement. Measurement is actually considered part of the on-stream inspection. We will also discuss common findings and damage mechanisms that are frequently encountered in pressure vessels. These include corrosion, cracking, metallurgical changes that affect material properties, and mechanical fatigue resulting from vibration or operating conditions. After that, we will discuss pressure vessel assessment. When we find indications during inspection, we need to determine whether they are simply indications or actual defects. We will compare them against acceptance criteria and allowable tolerances. If they exceed the acceptance criteria, they become defects. We will discuss how to assess these findings properly. 1 of the key assessment activities is calculating the minimum required thickness. This can be calculated according to the construction code obtained from the manufacturer's data report. If the original design calculations are available, we can use them directly. Otherwise, we can calculate the minimum required thickness using the applicable equations. We will mainly focus on ASME Section 8. After inspection and assessment, we calculate the corrosion rate, which represents the annual metal loss rate. We will discuss both long-term corrosion rate and short-term corrosion rate. This requires historical inspection data. Using inspection records, we can calculate both values. Based on corrosion rate and minimum required thickness, we can calculate remaining life according to API 510. Based on these calculations, we can determine the appropriate inspection interval. This interval will be based on the requirements of API 510. We will also discuss MAWP, maximum allowable working pressure, and how it is calculated. Once the assessment is completed, the vessel may be acceptable with monitoring or considered fit for service. In other cases, the findings may require repair. We will discuss common repair methods in detail, including both temporary repairs and permanent repairs. We will review the repair techniques commonly used in industry. After repairs, we may need to perform pressure testing. This could be pneumatic testing using nitrogen or air, or hydrostatic testing using water or another liquid. We will discuss the requirements and calculations for each test. After covering all these topics, you will have a complete understanding of pressure vessel inspection. We will then review practical case studies. We will learn how to prepare an inspection test plan (ITP) or inspection plan for a pressure vessel. We will discuss the requirements, preparation activities, and inspection workflow. The playlist will consist of 5 main sections. The first section is the introduction. It covers pressure vessel definitions, components, and common damage mechanisms. The second section focuses on inspection. We will discuss the 4 main inspection methods: external inspection, internal inspection, on-stream inspection, and thickness measurement. The third section focuses on assessment and calculations. We will calculate minimum required thickness, evaluate findings, and calculate corrosion rates. Both short-term and long-term corrosion rates will be covered. Then, we will calculate remaining life and inspection intervals. We will also discuss MAWP calculations. The fourth section focuses on repairs. We will discuss temporary repairs and permanent repairs, including the repair methods most commonly used in industry. We will also explain U-stamp and R-stamp requirements and when an ASME inspector must be involved in repairs. The fifth section covers testing, including hydrostatic, pneumatic, and tightness. Testing, we will discuss each type in detail when we reach that section. Let's quickly review the main references and codes we will use. The primary construction code for pressure vessels is ASME Section 8 most. Pressure vessels are constructed according to ASME Section 8 requirements. An authorized inspector must verify compliance with all requirements and documentation. The next important code is API 510. Another valuable document is API 572. It provides excellent practical guidance for pressure vessels, heat exchangers, and air coolers. It complements API 510 with additional practical details. API 571 covers damage mechanisms. It is essential for understanding corrosion, degradation, and deterioration mechanisms. API 577 focuses on welding. It provides guidance on welding, hot tapping, and welding metallurgy. It is increasingly important for API 510 examinations and field inspectors. Inspectors should understand welding methods, limitations, advantages, and metallurgy. Another important code is ASME PCC2, which covers repair methods. It provides guidance for developing repair procedures and selecting suitable repair techniques. ASME Section VI covers NDE methods, while ASME Section 9 covers WPS, PQR, and welder qualification. That is enough for today's introduction. This was a brief overview of the playlist. I hope the content will be simple, useful, and easy to follow. We will stay connected throughout the series. See you in the next video.